So hey guys, welcome everyone to my channel, and let's continue talking about cement unit. I'm going to cover in this video high pressure components of cement units, especially triplex pumps, gauge pressure transducers, and other part. In my last video, in my first part, we were talking about low pressure components, slotted mixing systems, centrifugal pumps, and now we continue step by step to know about cement unit elements. We understand how exactly a field operator work and handle with high pressure triplex pumps with all centers with high pressure line components. And let's dive into this. This is simple information based on my own experience. I'm a field engineer. Hopefully you'll find it useful for you. Let's get started. As I said, so we will consider these elements so listed below. In addition, we're talking about cement pump float 573 equipment, high pressure triplex pumps, positive displacement pumps are created to force cement slurry or any type of fluid into well through a high pressure line from fluid end. Principally as a transform of mechanical energy to fluid energy. The rotary motion of the drive shaft is converted into reciprocating motion. The plungers, pistons or whatever they're called, draw in fluid at a low pressure and expel at a high pressure, creating significant force, significant torque, rotates gear wheels, and it dramatically increases torque and then pump fluid and at high pressure. We know that in operation, we know the fluids circulates at our in wellbore as well under high pressure. Our cement unit has to possess suitable hydraulic energy, hydraulic power to move our fluids, convert from low pressure to high pressure. Now I'm going to explain you about the basic parts, basic components, basic features of a high pressure triplex pump. It consists of a chain case or a gearbox. So it is to increase torque from motion of drive shaft, from engines and from transmissions, and it's convert revolutions to high torque to move our ponderos, our plungers, high pressure. The power end is needed to create enough force to move plungers at any flow rate, at any pressure. So let's talk about basic physics concepts. The pressure equals force divided by area. In order to have high pressure, we need to create high force, big torque to move our fluids. Power end is like the assemble of crankshaft and big gear wheels. So in the fluid end, that consists of the valves, suction valve, discharge valve, and the plungers. This part of fluid end exactly pushes and pump our cement slurries to well. Now this is a Gardner-Denver triplex pump. So Gardner-Denver triplex pumps of positive displacement, and this is under this pump. This is a Halliburton HD 400. A field engineer pays attention to maximum pressure and flow rate in order to know about hydraulic power to perform a cementing job. This is key components: chain case or remember gearbox. This sprocket motions goes from drive line, from engine, transmission, input pinion shaft. A little sprocket rotates with this input shaft, and it moves big sprocket with output shaft, which it creates a huge torque. We convert rotation motions to reciprocating motion of this shaft. A typical twin pump layout. This is a drive line, chain case connected to power end, and this connects then to fluid end. This is a bulger, so huge wheels, the eccentrics, and this crankcase, crankshaft, and the pony rods attached directly to the plungers, and together it moves the plungers forward and back, creating reciprocating motions. Let's consider carefully how we're gonna pump our cement slurry. Discharge chamber. This is not suction chamber. This mistakes. So sorry for that. This is discharge chamber and lower suction chamber. So when we mix our slurry and we obtain the right level of density, so we need to move our fluid with the system of our centrifugal pump to fluid end of high pressure tube expand. So at the low pressure, when a piston moves back to power end, there is creates vacuum, difference of pressures, and suction chamber is open. Suction valve opens when pistons moves back to power end and fluid goes to this space between a piston and two types of valves. This is a discharge valve connected to discharge chamber. So then after we took our fluid, so we can displace it to discharge manifold, high pressure manifold with assistance of discharge valve. And then suction valve is closed, the piston and plunger move forward and it pushes under high pressure to high pressure line. Discharge valve is open. So we take our fluid under low pressure and discharge it high pressure. So we can see directional plunger when we're gonna suck our fluid, yeah, and then we're gonna to discharge our fluid to like a discharge stroke. This video. This is about the exact how high pressure tip expand works. Now here we can observe the rotational motion converts to reciprocation motion and to move our plungers and the creates fluid. Cement slurry. So this is a suction chamber, suction side, cement chamber, cement slurry flows here at low pressure and then the plunger makes a stroke, backstroke, and to discharge our fluid to high pressure line. And all this operation performs with assistance as two valves, suction valve and discharge valve. And next, this is a hydraulic part, fluid, and this is this is a feeling of special oil to lube our pistons, our plungers. This side is left side is power end and right side to discharge our fluid. This is a typical information so about slurry pumping. So we have cement blend prepared on bulk plant. We attach our cement bulk coiler to cement unit because it contains cement blend, and we're gonna mix water and cement blend and slurry chief or any type of slurry circulation system. We have centrifugal pump, we have the distometer, so we're gonna create our slurry design level of density according to cement program. So we're gonna transfer, we're gonna circulate our fluid, and then we feed to suction side of high pressure pump and displace our fluid so directly to well with a system of high pressure line and cement head. A couple of words about pressure transducers and pressure gauge. Pressure transducers is two types. Martin Decker, so we call the company 15K, 50,000 psi pressure range. So it locates on the high pressure line exactly after fluid end transducer signal and to system of control of cementing. For control of cementing operation, it shows data related to pressure. In addition to this, we have this pressure gauge, hydraulic gauge, to also monitor our level of pressure. This is the Halliburton cement unit. You know this is a high pressure line, and this is staff cementing control system because it contains a flowmeter, high pressure regulation because it's high pressure transducer, and flow meter. It sends data directly to laptop of engineer or supervisor and shows data related to cement pump operation. Accurate monitor and regulate cement pumping. Just a couple words. A cement unit of 320 is a Russian conventional machine with one high pressure triplex pump and with this displacement tanks. We use this stuff in order to like a backup in order to do displacement. After cement slurry pumping, we need to displace our fluid into analyst. So we use this machine to back up our cement unit like CPF. Yet, and in my opinion, it's not effective because we can't mix cement and water here because it has no any type of mixer or type of circulation system. But we can just displace our fluid at a high pressure, and also we can do like remedial cementing jobs when the volume of cementing is small, and it's like a simple operation like a pressure test. The basic thing just is to have a backup option in order to emergency situation will occur. This is the same cement unit, so we have a fluid end, we have a high pressure discharge line. Yeah, this is a power end, transferred also the rotation energy converts to reciprocating. And this is my favorite cement unit, CPF. Pay attention to this high pressure pump. So once we created the cement slurry with right level of density, so we need to feed the low suction side. Yeah, we need to send our cement slurry prepare cement slurry to suction side of this high pressure triplex pump. So we use as well our recirculation slurry or recirculation centrifugal pump, and we send our fluid to suction side to suction chamber of this triplex pumps. Then we discharge our fluid at a high pressure to high pressure line. We use these plug valves in order to control our flow operation, and so we can use this high pressure line. It's a really stunning and high effective cement unit. Different parts of this is like the displacement tanks. We can collect our water or drill mud in here. So slurry is produced in here at a mixed tank. So by circulation system, by centrifugal pump. I understand this. Also we have this storage can, and we have densistometer to monitor our level of density. And this is like especially additional hoses to transform our mixed water to system of slurry chief to mix our slurry. So different parts of the engines. I don't consider the stuff because it's relates to mechanics jobs. I made it by myself. I carefully performed the job on this unit. I was like this operator. I stand it and the stuff station density control unit call. So this is simple information, and anyone can obtain this knowledge. So as me, thank you for the watching, for the time. Hopefully this great benefit for you. If you have any questions or maybe any suggestions, please write comment below. I will gladly answer you.